The goal of this project was to initialize and set up UARTs and a Bluetooth module to allow for communication between a phone's serial terminal and two TIVA boards. We begin by configuring the board to the specified parameters. This is accomplished by sending a string of AT commands to the Bluetooth module while it is in command mode. The preceding video demonstrates that the module was configured. Next, two organizers of the program were made for the first and second microcontroller. The first program file is for MCU1 and contains the files for the UART_C, UART_BT, main, and port F. The UART_C file is very straightforward and configures the UART to allow for communication between the two TIVA microcontroller. Port C is utilized and the boot rate is set to 57,600. The UART_BT is set up to allow for communication between the MCU1 and the HC05 Bluetooth module. Since we did this through port D pins 6 and 7, we had to unlock the pin and set the control register. The rest of the initialization is as normal. The initialization on port F sets the pulse width regulation (PWM) for the onboard blue LED. The main file for MCU1 is designated to use the UART-BT to transmit a string message for the display on the phone's terminal. When the client has entered F or B followed by their number, the string is received and the data is used to determine the next functionality. If an F is detected, the numerical portion of the data received is stored in a buffer array. This value is then converted into a string. A for loop is used to compare the value of the entered data against a range of numbers. This is intended to ensure the entered data is within the range of the specified values. When a match occurs, the data is transmitted to MCU2. If AB is, the same procedure is previously stated as followed, only this numerical value is passed to the port F function to determine the onboard LED's brightness.
The second program file is for MCU2 and contains a UART, main, port F, and DAC files. Port F instantiates the TIVA LEDs for debugging purposes. Again, the UART instantiation is very straightforward. This is activated for port C pins 4 and 5 and is used to receive information from the first TIVA board. The DAC creates an array that digitally builds a sine wave. Then it initializes all pins of port B that provide the output to the 8-bit DAC. A SysTick clock is to periodically output the values of the sine wave array. The main uses the UART to receive data from the first TIVA board. The data is converted to the appropriate period and passes to the interrupt.